Well, thank you all for coming. This is another in the series of speakers that we're bringing as a result of the Talking Public Affairs Committee. And once again, our colleague Joel has arranged for Dr. Mass to come and talk about weather prediction issues. So, Joel, go ahead and introduce Dr. Mass.
Good evening. Hold it closer.
Hold it right up. Yeah.
Can you hear me now? Okay. Our guest this evening is Professor Cliff Mass. He is a professor of atmospheric sciences at the University of Washington. And more than that, he is somebody who has brought his academic and technical expertise to the community in terms of a very popular weather blog, and also in terms of he has been delivered weather segments in both of our public radio stations in town. He has also been involved intimately in the salvaging of what was KPLU radio and is now KNKX radio in its jazz format. He was instrumental in both lobbying to provide for the opportunity for the purchase of the station and also for raising the money that bought it, and has been unfortunately treated shabbily by the management of that station. And in a little bit more personal terms, he is somebody who has been responsible for my safety and the safety of a lot of other people via his Friday weather forecasts. Because if you see a lenticular cloud on the summit of Mount Rainier, this gentleman will tell you with greater accuracy than anybody else when the ensuing storm is going to hit the mountain. And he is also an expert when we have a situation in which we have a icy weather coming down out of the Fraser Canyon of British Columbia, and a storm coming out of the Gulf of Alaska, and when they may intersect and give us a substantial snowstorm. He can predict its arrival better than just about anybody else in the region. He has been outspoken in his views, and I think we are in for an extremely interesting hour, and I will be quiet and let it proceed. I give you Professor Mass.
Okay, let this work? Yes. Okay. Well, thank you for inviting me, and let me talk about two topics today. By the way, I'm a professor of atmospheric sciences. Actually, climate's in the title, and I do weather research and climate research. I do both of them. Anyway, today I'm going to talk a little bit about weather prediction and climate change, and it turns out they are extremely interrelated, very interrelated, as you'll see. And so, since who knows, I may lose you later on. Let me give you the take-home messages right now. Okay. Number one is that weather prediction has become immensely more skillful during the last few decades. I mean, if anybody makes jokes about meteorologists, it won't be favored here. Okay. And the other thing I want to mention is that this improved weather prediction is an extraordinarily powerful tool to reduce the effects of extreme weather. Okay. If you know it's coming, you can do something about it in terms of protecting populations or whatever. Then I'm going to also talk about climate change. That human-caused global warming, we'll call it climate change. I'm going to tell you something that may shock some of you. It's not an existential threat to mankind. Not. It is not a crisis. Okay, so people are already excited. And I'm going to suggest that this is a problem that we can address. Okay, so I'm going to talk about weather forecasting and climate, and you can see how they're both interrelated. The first thing is most people do not understand how good weather predictions become. And I'm sure you wouldn't do this, but a lot of people make jokes about forecasters and meteorologists, right? And you see cartoons like this, heads or tails or whatever, right? Well, it turns out weather prediction is much better than that. And so the first thing I want to tell you is about the underlying technology. The technology of weather prediction is the same technology as climate prediction. And it's something called numerical weather prediction. I do that. I run these computer models. I am a modeler. I do this stuff. Okay, and so how does this work? How do we predict the future of the weather and of the climate? Well, first we have to start with a description of the atmosphere, three-dimensional over the whole globe. You can't predict the weather unless you know what's going on everywhere, okay? So you need that, number one, a full three-dimensional description of the atmosphere. And then we have certain equations that allow us to figure out what the future is. If we know what's happening right now, these equations allow us to project into the future, okay? There's a version of those equations right over there, but there's a lot of these equations, right? And so what we do is we solve these equations on a grid that covers the whole planet, three-dimensional grid, okay? And that allows us to go forward into the future. For weather prediction, we only go a few days or a few weeks, but for climate prediction, we can go years or more. To do this, you need computers, right? Well, we couldn't do this before we had computers. And the first computer that was used for weather prediction is this one. This is the ENIAC that was devised during end of World War II to do ballistic calculations. But afterwards, we use this for weather prediction. So numerical weather prediction, we have to know what's going on right now. We have these equations that allow us to go into the future if we have the computing resources. But it's really important to know what's going on everywhere. And we didn't have this capability before the 1970s and 80s. And what made all the difference was this, weather satellites. The first weather satellite was TIROS-1 in 1960, and we didn't look back from there. So this is the basis of weather prediction. And weather prediction has become immensely more accurate. This is one of the most famous figures in meteorology. I don't know if you can see the dates on the bottom, 1985 there, 2020 over there. The higher you are, the better the forecast. And this shows you the skill of the forecast for 3 days and 3 days, 5 days, 7 days, and 10 days. Well, the main thing I want you to see, it's going up, okay? And it went up particularly fast between 1995 and around 2010. And that's when we had a lot of satellites up there and we got to know how to use them, okay? So there's a radical change in weather forecasting skill. By the way, a subtlety of this figure is the top, this is for each of these panels, the top is the northern hemisphere, the bottom is the southern hemisphere. Before a certain period of time here, the forecasts were much better in the northern hemisphere than the southern hemisphere because we had much more data in the northern hemisphere. But after we got the satellites in, the skill became almost the same. Okay, so we have these satellites, and so this is for global weather prediction. The global weather prediction got much better. But then there was another revolution that happened that made the skill of forecasting even better. And that is what I call the high resolution prediction revolution. We solved the equations on this grid, but once we had enough computer power, we could make the grid finer and finer and finer and finer. So we were able to define local weather features with our computer models, okay? Today we have enough computer power. The grids are spaced so tightly that we can describe local weather features even here in the Northwest. And just to show you how far we've come, on the left here is a state-of-the-art precipitation rain forecast back in 1995 in ancient days. And this is over the Northwest here, right? And the shading indicates where it's raining, okay? Do you see the mountains there? You don't see them at all. Now let's fast forward to 2015. This is a NOAA model that has the grid spacing is 12 kilometers, and all of a sudden we're starting to define the local weather features around here. Okay, it's pretty good. Just to give you an example, I ran this experiment myself on the model I use. This is 24-hour precipitation using 100-kilometer grid spacing. This is what we had like in 1995. My God, you couldn't see. This is where we are right now. You couldn't see the mountains, the effects of the mountains. This is what we had around 1995, 2015 or something. We can define the effects of the Olympics, the rain shadow, the cascades, etc. Okay, so we've had these revolutions in forecasting. And if you actually look at the skill of things like heavy precipitation, this is from 1969 to 2023, higher is better. The skill in forecasting, this is for 2 inches or more, are getting better and better and better. I could show you dozens of these things, okay? So weather prediction has gotten much better. So the key thing is satellites see everything. So we have 3-dimensional data over the whole planet. And we have computer power so powerful that we can run our models at very high resolution and get the local details, okay? This is what's changed. Okay, well, the implication, this has big implications. Our forecast skill has gotten better, and we are now capable of saving people's lives from extreme weather. I'll give you an example. Let's go back to 1970. There was a cyclone or a hurricane that hit in Bangladesh in India. It shows you the path over here. There's the hurricane. So it went into the area. You can see where the track was. And this is, I don't know how to even say it, the Ebola cyclone. Nearly 500,000 people died. And a lot of it from water surging onto land, okay, so the surge. Okay, that's 500,000 people died from one storm. A storm that was even stronger came in 2020 when weather predictions become very skillful, okay? And only 133 people died, okay? I can give you other examples of this. But extreme weather now, we can forecast extreme weather so well that we can save lives where we couldn't do it before, okay? So we have some protection from extreme weather. I'm giving you want a domestic example? 1938, okay? A hurricane hit the East Coast, went across Long Island, and about 700 people died, okay? Then we had another one that came in 2013, Sandy. Anybody remember that? Superstorm Sandy, okay? A lot more people in the area, and 248 died, and a lot of those people neglected the warnings. If they listened to the warnings, it would have been a lot less. And this thing was forecast almost perfectly a week before. We've come a long way. Okay, you want a local example? The Columbus Day storm. Anybody here remember the Columbus Day storm? Yeah, some people here. That's a good thing going to a group like this. The Columbus Day storm. Okay. And it went up the coast, made landfall north of us. And if this storm hit today, there'd be $30 billion of damage, at least. I mean, this was the strongest storm. The strongest non-tropical storm ever to hit the continental United States. This was an extraordinary storm. Okay. Was it forecast the day before? No. In fact, if you look at the Seattle Times the day before, they talked about it was a good day to go hunting up in the mountains and stuff, okay? It wasn't forecast the day before. But since around 1990, we forecast basically every single storm accurately. And just to give you an example, this was in the paper a lot, right? You remember the bomb cyclone of last November? Right? I think that was forecast days before. I have a blog, and I was blogging about it several days before, that this huge storm was going to form offshore. I even talked about the strong easterly winds, and they occurred, right? We nail these right and left now, okay? I mean, we've come so very, very far. Okay. I mean, just to give you an example of the progress we've made, sometimes we're so good and people don't listen to us, okay? For instance, what happened to at Maui, Lahaina, people are probably familiar with what happened in August of 2023. You know, that's the Maui Mountains, there's Lahaina. Strong winds descended down and started a fire. Here's a map. I don't have a pointer, but this is Maui. Here's the map. This is the West Maui Mountains. Strong easterly winds came down. Okay, started the fire and then drove the fire into town. Well, just to give you an idea of how good we are, I mean, I wrote a paper on this. The 24-hour forecast was almost perfect. Basically, you know, the locations here, the red indicates very strong winds. Okay, so we almost got this perfect 40 hours before, but we got it perfectly pretty much out to 137 hours before. So we knew what was going to happen, okay? And so this is a great success, but there's also tragedy in this story. I'm going to tell you the great tragedy of this weather prediction revolution that we have. There's a tremendous tragedy, and that is society does not always effectively use our forecast skill to save lives. I mean, over 100 people died there from a situation that we forecast almost perfectly, right? $5 billion of damage, near perfect forecast, okay? And this has happened time and time again. The LA fires, right? It happened earlier this year. This was for the winds that were coming down were forecast pretty much perfectly days before. I blogged about this the day before it happened. If you don't believe me, check my blog. I blogged that this was a tremendous disaster could happen in Los Angeles. The Weather Service did the same thing, and we couldn't stop it, right? Because they didn't take the steps that were necessary, okay? And to the end, 29 we killed. And this will probably be the greatest meteorological disaster in the history of the nation, right? And you know, the Weather Service. This is the day before the Weather Service put out this, you know, life-threatening destruction and stuff like that, and we didn't do anything about it. So anyway, so the story about weather prediction, you know, this is an important one. We've gotten extraordinarily good. We're saving a lot of lives, but there's a lot of things that are happening that could be prevented if they used our forecast better, okay? And our ability to forecast extreme weather situations is very important, and it's going to be important in the context of what I'm going to talk to you next, and that's about climate change, okay? So I'm going to talk about climate change, and this is going to be the more controversial part of this lecture, so be ready for it. I had dinner with some people. I can see I'm going to be walking on thin ice here, but I'm going to do it. All right. And I'm going to start by using one of my favorite quotes from Mark Twain. It ain't what you don't know that gets you into trouble. It's what you know for sure that ain't so. And I'm going to tell you what you think you know about climate change may have problems, okay? Okay, so let me give you my key messages here. Human-forced global warming and its impacts are serious issues. You know, we're warming the planet, you know, we're putting these greenhouse gases up, we're warming the planet, no doubt about it. This is a serious issue, okay? But unfortunately, there has been substantial misinformation in the media by activist groups and by some politicians. I'm going to suggest that climate change, you know, is a manageable technical problem, and it is not an existential threat to mankind. And it may be one that requires some adaptation and mitigation, but this is not an existential threat, okay? Okay. By the way, why should you listen to me, okay? You know, I've written dozens of papers, climate change. I've done that. I've also have tutored some people you know. When Jay Inslee wanted to get tutored on climate change, he came to me. Now, I'm not so happy with what he said afterwards, but he did come to me at that point, okay? So anyway, so maybe you can at least listen to me. Okay, so I'm going to stress that climate change, global warming, is not an existential threat. It is not a crisis, okay? And you'll see this in the media all the time. The media, what drives me most crazy is the Seattle Times. I've had a battle with the Seattle Times for years. And most of the things you read about climate change in the Seattle Times is simply incorrect and not factual. And Dave Horsey, their cartoonist, loves to have these balls of fire and stuff in there as well, okay? To give you an example, my separation of the Seattle Times started, back in 2012-13, where they had a story called Sea Change. I don't know if anybody remembers this. A big series of stories on sea change, and they were claiming the oysters in these were dying because of greenhouse gases. I don't know if anybody remembers that. Well, it turns out it wasn't true at all. It wasn't, they were saying that the oceans are turning acidic. It turned out their problem was they had these hatcheries for the oyster larvae, and they brought in water from upwelled water rising near the coast, which tends to be has a lower pH, and that was bad for the poor baby oysters. And after they realized their mistake, they didn't have a problem anymore. But the Seattle Times did a whole story saying this was due to human emissions of CO2, and it was totally false. Just again, I can't help myself. Here's another example from the Seattle Times. Ticks spreading in the Pacific Northwest. Warming trends could make it worse. The global warming was going to make the tick crisis worse here. Okay. And they talk about bloodsuckers are on the move, right? If that didn't scare you, you are really scared at this point, right? The bloodsuckers are after you. And because of global warming. Well, it turned out this was all nonsense. Hot, dry weather, which we do expect summers to get hotter and drier here under global warming. That's bad for ticks. And on top of that, there's no objective evidence showing that ticks have become more of a problem. Well, I shouldn't just pick on the Seattle Times. I should maybe pick on a few politicians around here, right? Here's an example I love to point out. Seattle's Mayor Nichols. Mayor Nichols did some great stuff. I just was at the harbor. It's wonderful what he did there. But he and others were suggesting that the snowpack was disappearing in the Cascades due to warming. And this is back in 2007. Well, it turns out, I wrote a paper that was in the peer review literature on it, and we can look back now. We're years ahead, and if you plot the snowpack in the Cascades, and this was done by Mark Albright, who was state climatologist. This is from 1985, 2000 something. If you look at the snowpack, it really is not decreasing in the Cascades. Now, it probably will decrease as we warm further. But so far, the loss of snowpack has been really quite minimal. And you can prove this. This is data, okay? Then, of course, there's Jay Inslee, okay? And, he actually made, this climate change was a big thing for Jay Inslee, right? That's one of his biggest things. Anyway, one of the things he talked about was they didn't have forest fires. They had climate fires, okay? And he's suggesting that the fires were increasing because of global warming, right? That we did. Well, it turns out that the evidence for this is really quite weak. It turns out that climate change is a very small part of why we have more fires. And by the way, I should tell you, I've published now about a dozen papers on this wildfire issue. This is what I do. I have grants on this thing. I'm working on this, okay? Fires, we've had a problem that we've suppressed fires for years, starting in the 1930s and 40s, and we eventually started paying the price for doing this, okay? So we've suppressed, and then we started to decide we weren't going to suppress them so much anymore. But we've radically changed the nature of our forests around here. Forests that used to have regular fires, and that have the trees spread apart in a way that wasn't too flammable. We ended up with this, okay, by suppressing fire. And when we get fires now, they tend to be much more catastrophic. Another thing is, in our region, we have invasive flammable grasses have moved in to all the forests on the West Coast. And that causes much more fires, and there's more human ignitions. So if you look at a plot over the western United States or the Northwest of the number of fires, this is from the 20s to roughly now, there used to be a lot more fires than we have now back in the early part of the 20th century. Then it declined when we suppressed, and now we're suppressing a little bit less, and we've messed things up. We're getting a little bit increase in fires, but it's nothing compared to what it was before. And by the way, there's paleo evidence that suggests this as well. So people say, well, they don't remember the smoke before, 20 years ago. Well, if you were 100-something years old, you would remember the smoke. And in fact, if you don't believe me, there's a quote by Mark Twain. Mark Twain was visiting here. I think this was I forgot that I should have put the date down. I think it might have been early September. No, but what part of the year? It was 1895, but I forgot what the date was. Anyway, he was invited to give a talk in Olympia, and the person who was running the meeting was apologizing. I'm sorry, the smoke is so dense you can't see the mountains. And he said, I didn't mind. I smoke a lot myself, right? Okay. One thing I want to make sure I'm bipartisan here. There's a lot of people on the left that have been hyping up the wildfire stuff and the climate change business. But there's problems on the other side too, okay? This is a bipartisan misinformation that's going on. This is a famous one. A senator brought a snowball in during a period and claimed, well, it's so cold that, the climate change is nonsense. And our president has made a few quotes as well that are not appropriate. So what I want to tell you is this is a bipartisan problem, right? Misinformation about climate change. And the truth is in the middle, folks. This is, we're warming the planet slowly. It's, it's an issue, but it's not the end of the world, okay? And we can deal with it. Okay. Let me give you a little bit of global warming 101. And I'm authorized to do this because I teach 101. And I'm about to do it in a few weeks. Okay. So greenhouse gases warm the planet. Okay. These are gases that warm the planet. Okay. The number one greenhouse gas is not carbon dioxide, it's water vapor. Okay. Number one. Then there's of the gases that were involved in carbon dioxide is the number one, then there's methane, nitrous oxide, and others, okay? So these gases called greenhouse gases. They warm the planet. We understand exactly how this works. I mean, we've known this for over 100 years, okay? Basically, greenhouse gases act like blankets. How do blankets warm you up? They don't provide, there's no heater in the blanket, right? But it makes you warmer. And it makes you warmer by retarding the loss of heat away from your body. And it has to warm up more near your body to get the same heat flux away, okay? So it works the same way as blankets. So we understand this greenhouse gas stuff really, really well, okay? CO2, carbon dioxide, is increasing, okay? This is from Mauna Loa Observatory in Hawaii. This shows you the concentration of CO2 over time. It's going up. Human beings are the main cause of it, okay? We're doing it, okay? And mainly from combustion. Okay? There's other reasons as well. Okay. Now, how much have we warmed up in the last 100 years? This is a plot of, globally how temperatures increased over time. And I don't know if you can see, it's from 1850 to 2025. And this is in degrees centigrade. This is in degrees centigrade. So, we'll use this as a reference. temperatures were relatively constant to about about 1925. Then it started warming up. And that warming up, we don't think human beings were involved in. Okay, that was probably natural. Okay, then it started cooling down a little bit. Okay, in the mid part of the century. And in fact, there were a lot of meteorologists that embarrassingly were predicting another ice age showing up soon. Okay. What makes it really embarrassing, I studied under a climatologist named Steve Schneider when I was young. And he actually did a paper about the coming ice age. Very embarrassing. He changed later. Then we started warming up, something around 1975. And this is probably what we did with CO2 in the atmosphere, okay? So we've warmed up now by roughly 1.2 degrees centigrade, okay? Roughly double that to Fahrenheit, okay? So 2 degrees Fahrenheit, 2 degrees Fahrenheit, that's what we've warmed up so far, okay? All right, what's going to happen? Well, there's all kinds of predictions. We run these computer models into the future. The big question is how much carbon dioxide is there going to be in the atmosphere? And there's some predictions that are assuming that we're going to burn coal crazy, right? And those predictions give you very substantial warming. There's some that's saying that, Al Gore will be president for the rest of the century, right? So, and we massively change things, okay? Well, right now, what we think is the most realistic prediction is somewhere between 2 and 3 degrees centigrade total warming by the end of the century. So basically, we've gotten about halfway to where we'll be. I think that's probably the most probable forecast of where we're going to be. So we're going to warm up by the end of the century. That's if we don't do anything exceptional. Okay. What are the implications of global warming for the Northwest? This is something I've worked on myself. Okay. Northwest windstorms, right? Talking about extreme weather, okay? And a good example of it is the Inauguration Day storm in 1993. I don't know if anybody remembers that. I remember that. So that was a big one. Are they becoming more intense? Is global warming making them more intense? Well, some of the media was suggesting that was the case. Well, it turns out the answer is no. And a number of us have done research on this. There's no trend to increasing intensity of the big windstorms. And when we look at climate model simulations, they don't increase. So the big windstorms are not going to increase here. Using the most reasonable climate models, it looks like the snowpack in the Cascades will probably decline by maybe 20 to 30% by the end of the century. Okay? With little change in precipitation. In fact, the total precipitation may go up slightly as the planet warms. So a little bit more precipitation, but less snowpack. Okay? Now the snowpack's important here because we use the snow as another way of storing water, right? So we'll probably have less water stored in the mountains. So what we may have to do is we may have to build more reservoirs, especially in eastern Washington, to store water. How about sea level rise? You see a lot. In fact, some people were talking about that when I was having dinner tonight. Sea level will rise as the planet warms because first water expands as water expands as it warms up, and also we have ice and snow over land that melts and the water goes in the ocean. Okay. Well, what's happened around here? Is sea level going up or down around here? Well, it varies, depending where you are.
Alaska's going down.
Right. In some places here, it's going down. So this shows you whether sea level is going up or down. And actually, sea level is going down in some places around here, and it's going up in other places. And the key thing is that we had the glaciers here on top of us, right? Big mountains of ice are over here, and they pushed the land down. And some of the land is still rebounding upward. And so some places where the land is coming up because of the ice is off of it, sea level is actually going down. Other places, it's going up. But one thing that's important to keep in mind is that there is no hint of acceleration of sea level rise. No hint. If you plot the level of the water any place away from where the ice was, And this is at Seattle, there's a slow increase in sea level, but it's not accelerating. Okay, so we're not talking about a crisis situation. Here's an interesting one. The media is constantly talking about the warming planet is going to cause more deaths from extreme temperatures, right? Have you seen that? I mean, you'd have to be dead not to see that, right? I mean, there's so many stories about global warming and people dying from heat, right? Okay, I mean, I could show you page after page of it. Okay, but here's the truth. Here's an interesting thing that you may not have thought about. People also die from cold. And it turns out way more people die from cold than from heat. And so if you're warming the planet, actually less people will die from extreme temperatures. Now, if you don't believe me, go to Google or Grok or something and ask. I did that question. There's the answer right there, right? Or you can look in the publications. This shows you the fraction of mortality due to moderate and hot and cold temperatures for various places around the world. Extreme cold is the blue, moderate cold is the light blue, and the red is from heat. And you'll see the cold kills a lot more people than heat. So actually warming the planet will actually cause less people to die from extreme temperatures. Okay. So, the bottom line I'm trying to tell you, I know for some people this is painful, but global warming is not an existential threat to our species. Not. Okay? And in fact, you don't have to believe me. You can go look at the document, the International Panel on Climate Change, IPCC. These are the leading people in climate come together to write this document, right? And they in that document, you will find this, that the gross world product will be brought down by 2.4% by global warming that goes unfettered. Okay? But that's not 2.4% down from where it is now. That's 2.4% from an immensely richer world. Okay? So we'll be slightly less rich. We'll be way richer by the end of the century. We'll be slightly less rich. The fourth natural assessment was very similar. It was only 1%. Okay. So what I'm telling you is, okay, we got global warming going on. It's kind of, some of it is baked in. We haven't caught up with what's happening in the atmosphere already. We're going to get some warming. There's no doubt about that, right? And so what we have to do is we have to work on adaptation resilience. We got to make society more robust to climate change. And around here, what does that mean? Bigger reservoirs, fixing the forests, getting people away from rivers if you can, okay? The other thing we need to do is we have to use nuclear energy more. And, we have not been expanding the use of fission in any way that we could have done this a long time ago. And we have new safe fission technology. But even more important than that, fusion power is going to happen. And it's a matter of time before it happens. So if it's not 5 years, it'll be 10 years. And if it's not 10 years, it'll be 20 years. But it doesn't matter that it's 20 years. If once we have fusion power, we'll have unlimited energy, basically, that doesn't pollute. And that changes the whole story. In fact, it's even better than that. Because if you have energy, you can pull carbon dioxide out of the atmosphere. I mean, we have technologies now to take CO2 out of the atmosphere, but it's not practical because it takes energy to do it. If we had unlimited fusion power, we could do it. Okay. So anyway, the big message of this is, society needs reliable information about climate change without hype and exaggeration, okay? And that's what I've tried to give you here. And I think with this, I am going to stop because I was told not to go too long and open it up to questions, okay? And do I call on people or do you do it?
We'll start over here, and Bill will have a microphone on the other side.
We've got a new lands commissioner. What's your opinion of him?
I don't have an opinion. A new lands commissioner, we'll see what he does. I mean, one way you can tell how good this land commissioner is, if he works to try to restore the forests, and that means thinning and taking all the debris out. I like to mountain bike on the eastern slopes with my friends, and to see what's happened to the forest it's terrible. If that needs to be fixed, if he does something on that, that'll be a good sign. It's too early to tell. Yeah.
One over there, and then you, George.
I was tangled up. What about the weather, or I don't know what they're called, satellites that are going to be decommissioned, dropped down, and whatever, that are no longer going to give people, meteorologists, a view that you're using now for your computer models?
Well, we certainly don't want to lose satellites. I mean, there's new generations that are planning to be launched. They've launched some recently, right? So we have, as a society, we have to make the investment to keep putting these satellites up and to put new technology satellites up. So we need to keep on doing this. I mean, we're in a better shape than we've ever been before. We have new generations of satellites that have been put up. I'll give you an example of it. We have satellites called RO satellites, radio occultation satellites. I mean, everybody has, you got a smartphone, right? You got a GPS signal, right? Well, by measuring the bending of the GPS signal, you can actually figure what the temperature and humidity is with height. There's a whole new generation of satellites that have been sent up. We got to keep on doing that and advance the satellites. So, got to do it.
Over here.
Yes. Is moving away from coal and petroleum products useful?
Is it useful to move away from coal and petroleum products? Is that the question? Well, in the long term, we should be able to do that to a substantial degree. We can't do it too fast. That's the problem. We're trying to do it too fast. And we're trying to do it in a way that is kind of elitist and kind of unequitable. So I'm not a great supporter in having enhancements of the gas prices here, so the richer people can enjoy the effects of it, can use energy, and poor people are penalized. So, I think in the long term, we're going to have to move it out, but I think we have quite a bit of time to do it, and eventually we're going to have, this nuclear power that'll be able to supply, most of the energy we need. I think there's some things that won't be able to be replaced so easily, like you have fertilizers that are dependent upon using, fossil fuels. Some things will be hard to replace. But in the long term, I think we'll move that direction.
This is probably a cheap shot. This is about the accuracy of forecasting.
Uh-oh.
Early last week, we had a forecast of rain on Sunday. As we got to Saturday, it was showers.
Yeah.
As we got to Sunday, there wasn't anything. What happened? Where is it?
Where did you get your forecast from?
NOAA. NOAA Weather, Seattle.
Okay. Does what I say here stay here? The most accurate forecast is not the forecast provided by the Weather Service and NOAA. Their forecasts are inferior to some others. For instance, if you ever want to see who's accurate, you can go to a website called forecastadvisor.com, and you can see who rate. The Weather Service is way down. Their forecasts are not as good as, let's say, the Weather Channel. You get the Weather Channel app. That's much better, okay? AccuWeather's better. So, unfortunately, the NOAA forecast is not the most accurate. Forecasts are not perfect. I'm not telling you they're perfect. They aren't perfect. And sometimes, especially when we have weak systems coming out of the ocean, there can be some issues. And especially exactly where, sometimes they don't have time to tell you how the precipitation varies spatially. That's a really interesting issue around here, is that sometimes the rain can be very different one place than the other because of the mountains, right? So there's a delivery problem. in terms of giving you the forecast for where you are. That's why I recommend you use something like weather.com, because they know exactly where you are, and it gives you a forecast tailored for exactly where you are. That may not be true for the Weather Service if you hear some area forecast or something like that. Okay?
The NOAA site is the UW.
UW is not a NOAA site. I don't know where in the UW you're getting it from. But I don't know. I'm sorry. Yeah.
Cliff, I wanted to ask you about your forecasting. For the Northwest is one thing, but what about intensity of storms worldwide? It seems to me the Northwest is somewhat insulated from a lot of stuff that you see much more of in the tropics and elsewhere. Can you talk about the worldwide
Sure.
forecasting?
Well, weather forecasts have gotten better worldwide. So there's no doubt about that. It's just not here. In fact, we're a place the forecast got particularly better about 20, 30 years ago, and that's because of the satellites. If you go into a time machine back into the ancient days of 1980, right, or 1970, we didn't know what was going on out there, right? And now we do. And so our forecasts have really, places like us on the coast have seen a dramatic improvement. But the improvement is worldwide. I'm not saying we're perfect. We're going to get better, and I can even tell you why we're going to get better. But the forecasts globally have gotten hugely better. And it's the combination of these better models, higher resolution in the satellites, that's done it worldwide.
Question back here.
So how do you feel about all the cuts that Trump is making to all the alternative energy sites? If you don't think anything is a problem, then you don't care if the wind doesn't get developed, et cetera.
Well, I think wind can be used where it's economically.
How do you feel about his cuts, is what I
Which
asked.
cuts are we talking about?
What?
Which cuts are you talking
Oh,
about?
well, he stopped the wind development, and he's cutting a lot of programs that were helping us. So if you're not informed on that, you can easily be.
Yeah. Well, in any case, I don't like to say that. I think it's reasonable to have a certain amount of wind energy and solar, but it's not going to solve our problem in the end. It should. That's the solution is not going to be solar and wind. The solution is going to be nuclear. The solution is going to be nuclear, not going to be solar. Because the trouble with solar and with wind is it's intermittent, it's not always available. Give you an example. Here in the Northwest, I follow the renewable energy generation very carefully. When we need energy the most, renewables become unavailable. In our greatest heat waves, in our greatest cold waves, that the renewables go virtually to zero. I can explain why, but they do. So the renewables are they're fine to a certain degree, but they are hardly the solution. And the real solution is going to be nuclear, either fission or fusion. That in the end, that's the solution. Yeah.
Okay. I'm wondering what your prediction is for agriculture in the Northwest, because sometimes even very small percentage changes really affect crops.
Yeah. Well, in fact, I have a grant, and I'm working with Washington State on agriculture here, and agriculture is doing quite well here. And I think is good. I think things look very good, and one reason is they're understanding how they can use the weather forecast better to manage the crops better, to protect the crops better during really cold periods. So I think there's no reason to be pessimistic about the crop situation. Pretty much, yeah. I mean, the climate's not changing that radically. And it really isn't. In fact, it would be nice if we had a little bit of different mix of crops. If we stopped using so much water for hay that we ship to Japan, that'd be nice. We waste a tremendous amount of water here. And it'd be nice if we were a little bit wiser using water for agriculture.
Yeah, I just
two things. One is I'm not as optimistic as you are about fusion, but another possibility is geothermal energy, which actually has a lot of the same properties of not being affected by weather in terms of ability to heat or cool. And I worked in a building where we had some geothermal power. But I think you did a good job of being balanced. And I'm lucky because I don't read a lot of the literature that is the scare literature. But a lot of people do, and especially younger folks. I'm thinking of some of my grandkids. So what's a way to change the landscape in the information that is available to the public, not in an adversarial way that says, good, bad, believer, denier. Well, how do you change that landscape and become a voice that is believable and trustworthy and tells people information in a way that they can open up and receive it?
Right. Well, I've been spending the last 20 years trying to do that. I have a blog. That's why I have a blog. I have a weather blog where I do exactly what you're saying. Exactly what you're saying. I've done it for 20 years. I have on a typical day 20,000 to 30,000 people who look at it, right? On a big weather day, I can have 100,000. So I try to do that, okay? And I'm not the only one. There's another people who try to do the same thing. The trouble is that the mainstream media is failing us. There's no other way to say it. The Seattle Times is failing us. Well, the PI is gone, unfortunately. But, my erstwhile radio station, KNKX, they're failing people too. So basically, we've had sort of this ideological capture of some of the media, or even more important, the media doesn't have the money to have reasonable journalists. The Seattle Times used to have a science person that, Hill Williams, I remember working with him, and Dietrich Henderson, really good people. Right now, a lot of people do the science stuff, or some temporary person who's just only been there for the last few weeks, doesn't know science or the local environment. So we're in a terrible situation right now. The traditional media is failing. There's some of us that are trying to move in with blogs and other things and Substacks and we're trying to do the best we can. But this is it's a very difficult communication problem we have now. Yeah.
What is your blog?
Cliff Mass Weather Blog. Just search on it, you'll find it immediately. Somebody up here? This side.
Let me rephrase the question I asked before. I wasn't so much asking whether the accuracy is global, but whether the predictions 10, 20 years out are for more intense storms elsewhere than here.
Oh, you're talking about the long-term predictions?
Yeah.
Okay. Well, for what I've seen, the answer is no, that they're not predicting more intense storms generally over the planet. The only exception to that, there are some of these models that suggesting that the worst hurricanes will get worse. The Category 5 ones will get a little more intense, okay? So I have seen that, okay? But for the general mid-latitude storms, like we get here, the answer is no, at least according to the models that I've seen.
Okay, here I am. I have a question about climate and wonder if you can answer these. There are insects that are living longer now because it is warmer, and they're quite destructive. And they used to be killed off by the winter cold, and that's not happening anymore. And they're decimating our evergreen forests, and I think that's something to be considered. And the other thing is, and we can demonstrate that right in our own gardens here at Horizon House, we have some trees growing downstairs that used to own the crepe myrtles. Crepe myrtles are a southern tree, but they grow quite well here. which they never, never did before because they couldn't handle our climate. How do you explain those two things?
Sure. Well, I'm hardly an entomologist, so I don't claim to be one. And it's certainly true we're warming. And so that means trees that were more comfortable further south can move northward. There's no doubt about that. In terms of the insect thing, I think it's more subtle than that. I think one of the reasons this has been said, we had some of this insect damage to the forests, is the forests have become so unhealthy and crowded that there wasn't enough water to go around for the trees because they were too dense. And that made them more liable for insect damage. I've certainly read that. But I don't claim to be an entomologist or anything. But I think sometimes it's more subtle than just saying it's warmer and the insects are going crazy. I think the density of the forests are important and other factors.
Well, but that doesn't explain the fact that the insects are not killed off.
Well, it's what?
It doesn't matter how many insects there are. The fact is they're not being killed off in the wintertime.
Yeah, I can't speak to that. I'm not an entomologist, but I do know that the vulnerability of the forest to insect damage depends on the density of trees and things like that. And so that has to be considered to get the full view of what's happening. Over here. Okay, go ahead.
Would you talk about what is happening to the islands in the South Pacific, which are being inundated by global, water warming?
It turns out that's not correct. It turns out there was all these predictions that these islands were going to be flooded, and actually the opposite happened. So if you actually check it out, you'll find out they're not flooding. What happens is they're rising with the water, that the coral reefs are growing, and they are not being lost. So that turns out to be not to be true. It is true. Check it out. It is true. It is true. It's definitively true. Okay. Look it up.
Any more questions? Well, Dr. Mass, thank you very much. Oh, we got one over here? Joel, go ahead.
Yeah, Joel has one. All right. The hard question.
When I was about 7 years old, growing up in Bellingham, the folks took me up to on the slopes of Mount Baker. Sorry, I'm slurring my speech, but the Coleman and the Roosevelt glaciers at that time were advancing. And now, years later, they have retreated substantially.
Right.
Glaciers always advance and retreat, but the speed at which they have been retreating, specifically the Roosevelt Glacier, which is pulled back maybe about a quarter of a mile, I'm deeply disturbed at the speed at which the recession is occurring, not only here, but also in the Columbia ice fields, also in Greenland and elsewhere. How, if this is not an existential threat, if it is not as severe as some people have predicted, how are we to explain and how do we accept the extent of the recession of these glaciers?
Well, there's no doubt that the glaciers are retreating now, and the warming is undoubtedly associated with it. But it's not existential. I mean, we may like to have that glacier there, okay? But it's not going to change whether you live or survive, or anybody else here. I mean, it's actually the water from the glaciers is a relatively minor issue in terms of survival of our species here, for good or for bad. So it's aesthetically, yes, but it's not an existential threat to the survival of our species, or even a major problem for the survival of our species. So, I mean, I know that sounds cold hard, but it's true.
Well, now let me get you on one more subject. I'm sure there are some people. Talk to me a little bit about what happens when you go against what is the majority opinion and some of your faculty colleagues, and what type of blowback are you experiencing?
Well, not very much, because remember, everything I'm telling you, I've published in the peer-reviewed literature. Everything I've said, I've written this stuff. It's been read by my peers. It's through publication, right? So why not this whole thing that 97% of climate scientists think exactly the same thing? That's all nonsense. I mean, there's all kinds of disagreements and stuff, but what I'm telling you is not, odd or off from the mainstream. It's not unreasonable. So I don't get much blowback in my department. I've said a lot of the same things in front of my colleagues. My department is considered to be the best in the world, and I'm not getting a lot of blowback from people when I'm saying a lot of things I'm saying right now.
Question? I lived in Australia for a while, and the reefs were bleaching. And is that something that you have anything to say about? Because it looked like it was kind of serious.
Well, there was a recent study that showed that it actually was much less of a problem than some people thought before. I'm not an expert in this area, but I think there's some controversy about that issue that I think you should take a look at. Oh, okay.
What's your opinion about the tipping point? Is there such a thing?
There's no evidence that there's tipping points. That thing has been pretty much dropped. There were people talking about it, but no, it was this bugaboo that we're going to go off this ledge. There is really no evidence that there's some tipping point that we're going to go off of, and especially that we have to keep global warming down to 1.5 degrees or 2 degrees. There's no support for that. It's really nonsensical. Yeah, the answer is no.
I'll ask one last question, and that is, given the misinformation that you've described that's abroad in the world, and given the fact that companies, local and globally, are reacting or not reacting, aren't there some very serious impacts economically around the world where there is inaction that could be and should be taken that you would advocate versus things that people are doing that are counterproductive?
I guess I don't understand your question.
Well, people either act or don't act. And an example would be, what kind of investments do we make if, in fact, there is serious global warming that's going to have real life impacts? And they may believe that if it's not true.
Well, all I can say is other countries are acting, like China and India, and their actions are massively to increase their emissions of greenhouse gases. So much so that we are now only maybe 15% of the problem right now here in the United States. So the other countries have made the decision, like China, that they value their economic advancement more than keeping CO2 down, right? And so they are massively increasing their emissions, and that's that's the reality right now. So what we do here, these things around the edges, it's meaningless, folks. The only way that we as a nation are going to really do something is by developing the energy systems of the future and having the rest of the world take it on.
And you're saying then that wind and solar are minor in that whole question.
Right. Wind and solar are minor. Right now in the United States, I think the number is 8.9% of our energy comes from these sources. Some things cannot be replaced by renewable energy. So, maybe we can get it to 10% or 15%. Okay, 20% if we're crazy lucky. Okay, but we're not going to get rid of fossil fuels until we have new energy sources that are dense and cheap, And folks, we have one already that we're not using, and that's fission. And then fusion will be the one that really makes the difference.
Okay, thank you. Well, I think that's enough. Let's give it up for Dr. Math.